Welcome again to the continuation on the laws of logarithm that I started with you in the previous videos. In the previous videos, we started learning about the laws of logarithm, and we've already established the first and the second law of logarithm in the previous videos, which is the product rule and the quotient rule. We've done a detailed explanation on it, and I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to proceed and look at the third law of logarithm, and that is the power rule or law. As you can see from the board, I've written power rule or law on the board. Okay, so that is what I want us to prove or establish in this video, and I will encourage you to do all to watch the previous videos, because the previous videos lays the foundation. There are a lot of things that I've explained in detail in the previous videos that we are going to use that knowledge here as well. So if you don't have any knowledge on what we've done in the previous videos, then you might struggle with this session. Okay, so please do well to watch the previous videos so that you can easily handle this session as well. And please don't forget to like the videos and also share them after watching. And if you're watching for the first time, please do well to follow the page and also subscribe to my YouTube channel as well. So let's go ahead and prove or establish the power rule or law of logarithm. Okay, so now I'm going to suppose some basic log definition. As we have been doing in the previous videos, we just suppose some basic log definition to be able to establish the laws. So it's the same thing that we are going to apply here as well. Okay, so let's go ahead and do that. So I'm going to say, suppose we have that log s to the base a equals to b. Okay, so we are going to use this basic definition to be able to prove or establish the power rule of logarithm as we've done in the previous videos. Okay, so we have that log s to the base a equals to b. So this is what you are going to use. This is the equation that you are going to use. Now, I'm going to pick this equation and write it in a form that it doesn't contain any more log. This I've explained a lot in the previous videos. Okay, so having that log s to the base a equals to b, you can see that it's an equation that contains log. So I want to write it in a form that it does not contain log anymore. And that is what we learned in the previous videos, how to convert some basic log equations into exponential form. It's the same thing that we are going to do. We want to apply that knowledge here. Okay, so all that we need to do is that we are going to maintain the s here, write your s, and this base, which is the a, it will come and carry the b here as a power. So it's going to be a to the power b. I hope you understand and you agree with me. Okay, let me go over one more time. Having log s to the base a equals to b, I want to rewrite it in a form that there will be no more log inside. How do I do that? Just maintain your s, which is here. The base a, which is here, will come and carry the b here as a power. So it's going to be s equals a to the power b. As simple as that. Let me use other example to explain it to you. Let's say I have log a to the base b equals to c. Okay, I want to write this in a form that there will be no more log inside. And I'm saying that all that you need to do is that write your a, which is here, bring your equal sign, and the base here, which is the b, will come and carry the c as a power. So you are going to have b to the power c, as simple as that. So that is what we did, okay, to get this, and I hope you understand up to this point. So let me clean this from here and let's proceed with the proof, okay. So now I have from here that s equals a to the power b, okay. So the next thing that we are going to do is that we are going to raise each side of the equation to the power n. I'm going to repeat it one more time. I have s equals a to the power b. So the next thing is that I'm going to raise each side of the equation to the power n, as simple as that. So when I take this side of the equation, I'm going to raise it to the power n, and when I take this side of the equation also, I'm going to raise it to the power n. Okay, so I'm going to have s to the power n equals a b to the power n. So this is all that I'm saying. We got here, we have s equals a to the power b. To proceed with our proof, all that I'm saying is that because we want to establish the power rule, okay, or the power law, the next step is that each side of the equation, we are going to raise it to the power n. You can use any variable that you want, it doesn't change anything, okay. I just chose to use n. Okay, so I'm going to have s to the power n equals, then this also I'll raise it to the power n, as simple as that. So let's go ahead and simplify further, okay. So this power n will affect the s, so I'm going to have s to the power n equals, then this power n, knowing the laws of indices, I've taught you indices in previous videos, okay. So we are applying that knowledge here. So if you don't have any knowledge on indices, please do all to search for the videos that I've done on indices. I've treated indices as a full topic. We've explained into detail and we solved a lot of examples on it. Okay, so do all to search for those videos in case you don't have any knowledge on indices. Okay, now the exponent rule of indices, or the power law of indices, it says that having a to the power b, all being raised to another power, which is n. To simplify it, you just need to use the power which is outside the bracket to multiply the power inside the bracket, as simple as that. So this power n will multiply the power b which you have here. That's the law. Okay, so I'm going to have a to the power b n. I hope you understand and you agree with me up to this point. Okay, now the next thing that you are going to do here is to introduce our log, okay, because we need to establish the power rule, okay, and we need to bring in the log to be able to do that, because in the premise we've said that the log of s to the base a equals to b. So we need to introduce the log here. How do you introduce the log into this equation? We just need to take log of both sides of the equation, as simple as that. So I'm going to take log of both sides. So I'll take log of this side and also take log of this side. Whatever you do to the left hand side, you do the same thing to the right hand side as well. So I'm going to have log of s to the power n to the base a. Bring your equal sign, and we are going to take log of this side also. I'm going to have the log of a to the power bn to the base a, as simple as that. Okay, that's how to introduce the log. So we take log of both sides. So I have log s to the power n to the base a. If you are wondering where from the base a, from the premise we've already established that log s to the base a equals b. So if you are taking log of both sides, then it should come with the base a. I hope you understand, because that's what we've established at the beginning. So that's why I have the base a there. Okay, so taking log of this side, so log s to the power n to the base a equals, then take log of this side also, log a to the power bn to the base a. As simple as that. I hope you understand and you agree with me up to this point. So let's proceed and do some basic simplification. Okay, now I'm going to repeat my log of s to the power n to the base a here equals, then this one I will rewrite it in another way, which I've explained a lot in the previous videos. In the previous videos, I taught you that, let's say we have a log s to the power y, okay, let's say to the base z, and I want to write it in another form. All that I will have to do is that the power which is here, which is the y, will come and become a coefficient to the log. Are you okay with it? I've explained this a lot. So this is a property in logarithm that we've established in the previous videos. So this power y will simply come and become a coefficient here. So we can rewrite this whole thing as y log s to the base z. As simple as that. So that is what we are going to use to rewrite this one in another form to look like this. Are you okay with it? So let me use one more example. Let's say I have the log of a to the power b to the base c. If I want to write it in another form, this power will become a coefficient to the log here. So I can write it as b log a to the base c. As simple as that. So the power here simply becomes a coefficient to the log. So we can express this in this form. I hope you understand up to this point. So we are going to use the same understanding to rewrite this one. Okay, so let me clean this one from here and let's proceed with the proof. Okay, so now writing this one in another way, the power here will come and become a coefficient here. So I'll have b and log a to the base a. So as I said, all that you need to do is to move the power here to become a coefficient to the log. So bn log a to the base a. I hope you understand up to this point. Okay, so now let's proceed and solve further. There's another property also that I established in the previous video. I said that the log of any number to the base of that same number is always equal to 1. So don't forget that. So having log a to the base a here, you should know that that will be represented by 1, because we've established that when I have, let's say, log s to the base s, it should be equal to 1. If I have log 5 to the base 5, it should be equal to 1. So that is the property that we established in the previous videos, that the log of any number to the base of that same number is always equal to 1. So keep that in mind. We are going to apply it here. Let me clean this from here and let's proceed. Okay, so now I'm going to repeat what is here. So I have log s to the power n to the base a should be equal to, now don't forget, the log a to the base a will be equal to 1. So I'll have bn multiplying 1, because as we said, log a to the base a equals to 1. So in place of log a to the base a, I'll put 1 there. So your bn is here multiplying 1. I hope you understand and you agree with me up to this point. Okay, so now let's proceed and solve further. So I'll have my log s to the power n to the base a equals to bn times 1 remains bn. I hope you understand and you agree with me up to this point. Now from here, let's go back to the premise. We said that log s to the base a equals to b. Have you seen it here? So it means the value of b equals log s to the base a. So in place of the b here, we are supposed to put the value here, which is log s to the base a. I hope you agree with me. So all that you are doing is to do a substitution of the value of b. Okay, so I'm going to have that my log s to the power n to the base a should be equal to, now the value of b here is log s to the base a. So I'm going to write it there. So I'm going to have log s to the base a, and the n is multiplying it. Okay, so let me put it into brackets, b multiplied by the n. As you can see, this is the n multiplying the b. The value of b is log s to the base a, and the n should come and multiply it. As simple as that. I hope you understand. Let's rewrite it in a more nicer way, so that this n will come in front of the log, okay, because it's multiplying. So I'm going to have log s to the power n to the base a equals to n log s to the base a, and this is the power rule of logarithm. I hope the explanation was clear enough and you understood it. So this whole thing that you see here is the power rule of logarithm. So it says that having log s to the power n to the base a, it can be rewritten in another form. Which form is that? The power n here will simply come and become a coefficient to the log here. So that's why you have n log s to the base a. Okay, as simple as that. I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share the video as well. I'll see you again in another video whilst we use all these laws to solve questions. Bye bye.